Hello,
Hi.
what do we have in store today?
Continuous integration.
Okay.
Seeing how seeing how different pull requests actually work with master.
Okay, yeah, so watch this. Let's create another branch. Let's call it CI.
Yeah.
Okay, I'm on the new branch called CI. Now let's create a file.
Wait, what are we using though? Which CI tool are we using?
We'll see. Just watch. New file. We have to name this file with a very specific name.
Yes.
Travis.yaml.
That gives it away.
That gives it away, I suppose. Travis.yaml. Okay, let's create this file. In this file, we have to say what is the programming language we are using.
That's Java. Okay. That's straightforward.
Have you ever heard of YAML?
Yes.
It's just a notation for writing JSON.
Yeah.
Except that it's more readable. You have less of the curly braces and everything.
Yeah. It's English basically with semicolons.
It's English with semicolons. Okay. So we have to say the language, and we have to say what is the version of Java that we are using. We are using OpenJDK.
OpenJDK 12.
Yes, we are using the latest Java version. That is Java 12.
Yep.
So let's save this file. We will commit and push to this branch.
Okay.
So configure Travis.
Yeah.
Commit and push.
Yep.
What did I just do?
I have no clue.
So what I just did is I created this file that configures this tool called Travis. Travis or Travis CI is in the toolbox. Let's go to the toolbox. Is it in my history? Yes. In the toolbox, we have this tool called Travis CI for continuous integration.
Yep, that's what we want to look at.
Continuous integration.
Next time.
Thank you.
Yeah.
Continuous integration is you have all these branches, all these features you are working on. And it used to be the case that people took a long time to get those changes into master and to deploy.
Yep, someone has to test them and like go through the code and see if nothing else on master is breaking if you actually merge it.
Yeah.
So Travis makes it easier.
Yeah, well, in big companies, it's still the case that people take a long while to deploy some features.
Yeah.
But there is this trend of continuous integration, of integrating the changes continuously into the main timeline and deploying those changes as soon as possible to the users.
Yeah. Especially in a lot of open source software where people like the maintainers don't have that much time on their hands and they're looking for people to contribute. So they have a set of tests that need to pass whenever you send in a pull request or anything. And then Travis can just check it, and then the maintainer or the human comes into the loop and sees if functionality is correct or stuff like that.
Yes. And the purpose of the continuous integration server is to help you with continuous integration. So what we are doing here is we are on a branch called CI. And in this case, the only thing we did in this branch was to configure Travis CI, but usually you are deploying or you are developing some feature or fixing a bug or something. What the continuous integration server does is anytime you push to GitHub your changes on this branch,
run automatically.
It will run all those tests we have been writing. In the previous episode, we wrote tests.
A simple test, for getters and setters.
Yeah, it was a very simple test, but it was an automated test nonetheless.
Yes.
And what the continuous integration server will do is to run those tests. So we can get some feedback right away as to whether the thing is ready to be merged.
Yep.
Whether we can.
If the versions are incompatible, there's a ton of stuff that you can actually get out of CI logs.
Yeah, and it helps you integrate the software back into master, which is ideal. Also, it helps with those works on my machine mistakes. Because Travis CI is another machine, so if it works on the continuous integration server, you can always say, if it's not working on your machine, Yash, that's a problem with your machine, not with the code base.
So every time Travis boots up a new virtual machine on its end and it downloads everything that you have, whatever code you have or any dependencies that we've downloaded through Gradle locally, and then it'll try to run it. And if the build passes, you're good to go. If not, there's some issue.
Yeah, so I want to go to GitHub and show how everything is connected, because this was done years ago. So definitely off camera. We did all this configuration years and years ago when we were first adding Travis to our toolbox, which I think happened in like 2015 or 16. What we did is we have this organization, and we went here to settings and installed GitHub apps, and we installed Travis CI. And that's something we did by going to travisci.com and following the steps there.
Yep.
Now this thing is installed for the TODOOSE repository, also for any
All
repository under our organization. We can come here to configure, and we can see that it is allowed for all the repositories in the organization, including your group projects and any repository you have under our organization. So that's how we integrated GitHub and Travis CI. Now that we have done that, Travis CI is watching for all the pushes on our repositories.
I don't like how you're saying watching, but okay, it is.
Well, that's what it's doing.
It has read access to.
Yeah, it has read access to, read access to code. That's what it's doing. So anytime we push, Travis looks for this file called .travis.yaml. If it finds that, it knows that, oh, so this is you asking me to run the tests. To run something, really, yes. To run the tests on Travis, on travis.com. And that's where we are right here, travis.com. If you look for Travis online, you may find travis.org. That is outdated. It's legacy.
Old,
and they are trying to phase it out. Go to travis.com instead. And here, let's see if we have something on the, configure Travis. So while we were talking, Travis noticed that there was a Travis YAML file, and it started to run the tasks that we told it to run. Well, but we didn't really tell Travis what to do.
So right now, Travis is just trying to install your code, like it's pulling your code and it's installing dependencies and seeing if that, like just the whole structure works on a random virtual machine. We've not specified tests here to point you to the test that we wrote yesterday, but that still means that does not mean that Travis will just forget about it. If it finds a travis.yaml file, it will just try to build your project from scratch on a virtual machine so that you know that whatever you've got working is not working just on your machine. It can be deployed somewhere else.
Yeah, so how is Travis figuring all this out? Well, it's following conventions. I told Travis that we are using Java. And we had to say which version of Java, because we are using a newer version of, instead of, I think, Java 8, which is the default. But in any case,
it's old.
I'm not sure it's 8, but it's an old version, and we want the latest. So we had to tell it the version. But once we did that, Travis was smart enough to try to figure out, okay, so I'm using now Java. What is your build system? Is it Gradle? Let's see if there is a build.gradle file. Oh, yes, there is. Awesome. So let's look into this file. Oh, now we see that we are building with these dependencies. So let me go get the dependencies. And now, usually the thing you want to do in a CI server is to run the tests. Is there some configuration for running tests? Oh, awesome, there is. So let me run the tests. And then if all the tests pass, then we say that the build has passed. And that's what you see right here. So let's look at this log and see everything happening. So first thing is, it's installing the version of Java we asked. We also get some system information here.
This is how it's booting up stuff.
Yeah, it's saying, oh, I know that you're talking about a Java project. This is the version of the operating system that I'm running. I'm running Ubuntu.
Xenial Zeros, by the way. And if you're interested, Ubuntu's releases have a very interesting naming convention.
Yeah, it's usually...
like, it's an alliteration. So it's always, let's say, Xenial Zeros or... what was it? So many weird ones. I've forgotten all of these. It's basically like so every release comes out. It's supposed to be. It goes from A, B, C, D, and so on, and it'll basically be the next alphabet from the previous release, and it'll be an alliteration. Yeah, I have forgotten this, which is not good. But yeah, you can see Disco Dingo.
This Codingo is the latest, and we are running on this
Trusty
version.
tar is what the So the catch here that you see on the screen is it's 14.04, 16.04, which is every 2 years. But the build Ubuntu comes out every 6 months actually. Every 2 years is the LTS, which is the long-term service. Like the support for it is like 5 years or something.
Yeah, the end of life of the version that was released on 2016.
Oh, it's 10 years. Yeah, 10 years.
No, it's not 10 years because it's
here it's 8, here it's 10. For 18 it's 10.
Oh, it's 10 years. Yeah. Amazing. So they're supporting this for 10 years.
Yep, exactly.
Anyway, we are running on this version of Ubuntu, but never mind the version of Ubuntu. Let's go back here. It's telling you everything about the system in which it's running.
Yep.
Awesome. Okay. Next, it's installing Java on the version that we asked it to.
Yeah, explicitly.
Next, it's pulling from GitHub our code base.
Yeah.
Which is in this address.
Yeah.
And then it's showing us the version of Java. It's installing some things with Gradle W. So Gradle W is something that exists in our repository. We can come here to IntelliJ and we can see it. It's Gradle wrapper. If you want to run Gradle not in IntelliJ, using double clicks here, you can double click on the tasks. For instance, to build, I think it was called assemble. So you could double click here, and that would do the same thing that Travis was doing.
Gradle W assembly.
Yes, but if you don't want to do that on the command line, like I have a command line right here, you would say Gradle W assemble.
Yep, that's it.
And so that's what is happening here. The build is successful. It's compiling and fetching dependencies, downloading everything. I can do that on the command line. And it's also successful, and that's what happened here in Travis as well.
Yes.
It's running assemble. It's downloading Gradle itself, then downloading all the dependencies like Javalin, SQLite, and then it's running the tests. So the test that we wrote in the last session passed. So
that works.
The whole build was successful.
Yes.
Are you limited to running tests on the CI? Not really.
You can do a lot.
You can do whatever. You can run any commands you want. You can come here to Travis YAML
and actually configure it as you please.
Yes.
Okay, this looks too cluttered. You can just shut off that window.
You can come here and say script. I don't want to necessarily run Gradle W assemble or something. No, I want to, I don't know, deploy somewhere.
If you have a separate script, you can just run that in CI and see how
you can do whatever. The CI usually runs tests, but it may deploy, it may notify people that something is wrong, it may monitor your code, whatever. It's just a machine that runs tasks.
Yes.
By default, the tasks are the tests.
So we will actually show you how more of this works, in the sense that we're going to do this with deployment, and then you will be able to see different versions, like a different use case of Travis CI.
I don't think we are going to use Travis to deploy, but we'll see about that when we deploy, probably on the next session. But before we go there, I want to show the pull request and how it works alongside GitHub. So we pushed to this branch, right? So we can create a pull request. So configure Travis is a good name. Let's create a pull request. Now, what is cool about this Travis and GitHub integration is that we don't need to go to Travis to see the result of the build.
It will come here.
So now that we have Travis installed, because we have the Travis YAML file, in GitHub, when we create a pull request, we see, okay, the branch is ran successfully. That is what we see here. Also, for some reason, it also runs the thing again for the pull request itself. So now we can come here to pull requests, and it's building pull request number 7, which is the number of this pull request. So it's running now the same tests again. And if all this passes, then this button will turn green. Which is a good indication of, everything is passing.
Good to go, you can actually merge it.
So I wanted to show this as well. And it kind of takes a while. Now you get to see, because when it was running the previous build, you were talking.
So you didn't know.
But you can see that it kind of takes a while, because it has to do all the things. It has to download Gradle. It has to download the dependencies.
I think it'll still be faster than what it was, but
I think that there are some things it tries to optimize from build to build.
Yeah, it'll have some sort of a cache.
Yeah, I don't know if you have to enable that cache, because it seems to be downloading Gradle again,
every time, yeah.
which indicates that the cache is not active, and I would have to set it up manually. But because I don't know how to, I won't.
Yeah.
And I'll just take, like, I wait 5 more seconds to see that the build was successful. And if the build is not successful, if I have a test that fails, this thing will be red,
yes.
and I will get to see the errors here on the log.
Yeah. And there you go.
Green button, merge pull request, confirm merge.
Done.
And that's the end of the story for now.
Yes.
On the next one, we can do one of two things. We can either go to deployment, but I would prefer to follow up on that thing about Javalin.
Javalin, yeah, I think that's a good idea.
Yeah, remember
I can't believe they had a documentation error.
Yeah, the documentation wasn't matching the thing we were trying to do in IntelliJ. Something was odd. Yeah. Well, I got in touch with the maintainers of Javalin, and I figured it out. We were wrong. They were right. And I'll tell you why.
See, that's a surprise.
On the next episode.
All right.
All
okay,
right.
we can do that next time.
Yeah, see you on the next one.